start with some more problems on DFA. So right here this problem, one DFA is given. Now we have to find out that out of the strings, 3 strings are given. Out of the strings, which strings will be accepted by this DFA. So let us start with 0 0 0 1. So it is very easy. We have to check that whether this string will be accepted by the after accepting this string, whether the machine will reach the final state, that is Q1 or not. So a 000 is there, 000 we can move within this Q0, and after that when it gets 1, it should reach to Q1. So 0001 will be accepted by this machine. And what about 01? If I give 0, it will move within the inner loop, and if I give 1, it will goes to Q1, then 001. So I have to check that whether from Q1 to Q2 what should be the input. The input is 1 basically. Sorry. So from 01, after getting 01, it will take again 0, and after that when it gets 1, it will again reach to Q1. So basically this string will also be accepted by this machine. And what about 40? When it will be in 40, then it will be in Q0, then after that 1, then 1, and then 0. That means it will remain in Q2. So third one will not be accepted by this machine. So these types of problem may come also during the exam. Apart from that, it is not only like that every time the language will be given, you have to construct the DFA. Now move back to the basic problem, that language is given and how to create the DFA for that machine. So earlier we have shown that if a string started with A and end with A, and in between them there may be any combination of A and B, how this machine will be accepted by this DFA and how to form this DFA, and the concatenation of the same string, how it will behave. Now let us move to a little bit complex problem. Suppose one language is given. I am actually searching for the problems. Here, right here I got this problems. So the basic problem that we have earlier have done when the language to grammar construction, that is a language is given that mod omega mod 3 equal to 0, where omega belongs to sigma a comma b. Means that already we have discussed that what is omega. Omega may be any combinations of A and B, but we have to consider the length of omega, and that length of omega modulo division of 3, that must produce 0. That means if mod omega is 4, that means 4 mod 3 is 1, that is not equal to 0. If mod omega is 6, then 6 mod 3, that is 0. So if a string having the length of 6 will be accepted by this DFA or machine, and if a string of having the length 4, it will not be accepted by this machine. So how to design such kind of DFA? First of all, think about that if the length is 0, then whether it should be accepted by this machine. Obviously yes, because 0 mod 3 is always 0, so it should be accepted by this DFA. So if a machine when it is not consuming any alphabets, that case also it should be in the final state. So Q0 we are making at the final state. Now when either it is accepting A or B, irrespective of accepting A or B, it will reach to Q1 state. But at Q1 state I can say that the length of alphabet that the machine has consumed is 1, and if the length is 1, then 1 mod 3 is obviously 1. So, it will not be accepted by this DFA, right. Now, if it accepts again either A or B, then what will happen? Let us see. If it accepts either A or B, it will reaches to Q2. So, at Q2, the length of the string that the machine has consumed is 2. So, this case also that one will not be accepted by this DFA, and again if the machine accepts either A or B, then what will happen? The length of the machine will become, the length of the input string that has been accepted by this machine is 3, and 3 mod 3 is equal to 0. Means that when it has, I am summarizing the problem. At Q0, the consumed alphabet is 0. At Q1, the length of the string is 1, which is not satisfying, and when it reaches to Q2, the length of the string is 2, which is not satisfying. Again, when at Q2, again when it is accepting a single string, either it may be A or B. So, the length of the string will be 3, and it is accepting, and it reaches to the final state. Again, if it accepts any one of the string, the length of the string will become 4. Again, another string it has accepted, the length become 5, and which are not satisfied by this machine. And again, if another string is being accepted, the machine will again reach to the initial state, that is the final state. So, in this case, initial state and final state will be same. And another thing is that the length of the string, where what we are getting over here, that it should be 0, 3, 6, 9, 12, that means integral multiple of 3. Now, if it is clear that mod omega mod 3 equal to 0, then it should be the DFA, right. Now, the thing is that if the mod omega mod 3 not equal to 0, that case what should be its DFA? Then if mod omega mod 3 not equal to 0, that means if the length, if I consider only the length of omega, length, that means mod of omega, if it is 0, it will not be accepted. If the length is 1, then it will be accepted. If the length is 2, then it will be accepted. If the length is 3, it will not be accepted. If the length is 4, it will be accepted. Length is 5, it will be accepted. Length is 6, it will not be accepted. Length is 7, it will be accepted. Length is 8, it will be accepted. Length is 9, it will not be accepted. So, except integral multiple of 3, all other strings will be accepted. So, it is very easy. That case, what I have to do, that the initial state which one I have make it as a final state, Q0, which one I made it as a final state, remove that, and rest of Q1 and Q2 make it as a final state. Then it will solve my problem. That means, at Q0 the length of the string is 0, which will not be accepted. At Q1 the length of the string is 1, it should be accepted, and at Q2 the length should be 2, it will be accepted. Again at Q0 the length is 3, it will not be accepted. At Q1 again the length will be 4, it will be accepted. At Q2 the length is 5, it will be again accepted. So, in this way it will move. Okay. So, again coming to little bit more complex problem, that if for the string LG a b to the power 5 omega b to the power 4, where omega belongs to a b whole star. I think it is not that much visible. I should change the color. Now, it should be okay. A b to the power 5 omega b to the power 4 means that omega may be any string, but it should start with a single a and 5 b and end up with 4 consecutive b. So, how to go up with this problem? Again, this types of problem already I have done. If you can remember that a omega a or a omega 1 a omega 2 a. So, the same policy will adapt over here. At Q0, what you will think that what are the minimum string that is required to reach the machine to the final state. Let us find it out. So, if omega become lambda, that means the length of the strings will be minimum amount of string that will help or enable the systems to go to final state. Now, if omega equal to lambda, that case after accepting single a and 9 b, it will reach the final state. So, let us do it. at q0, when it gets a is the valid string at q0, at q1 b should be the valid string, q2 b should be the valid string, at q3 again b should be the valid string, here also b should be the valid string. How many strings? 1 2 3 4. q5 b should be the valid string, q6, then q7. How many b? 1 2 3 4 5 6 7. So 7, I need 9. Okay, 2 more, q8 b, then q9. Okay, so after taking a single a and 1 2 3 4 5 6 7 8 9 b, it reaches the final state. So this is the basic thing, that when omega becomes lambda, how the machine reaches to the final state. Now let us move back to the other conditions, that at q0 if I give b, then what will happen? At q0 if I give b, b is an undesirable inputs at q0. If it gets b, there is no chances of getting a b to the power a b5 omega b4, right. So it should reaches to the trapping state. Now at q1 if it gets a, is there any chance to get the entire valid string, that is a b5 b4 omega b4? No. So again, if at q1 if it gets a, it should reaches to the trapping state. At q2 also similarly, a is an undesirable input. At q3 again a should be an undesirable input. How long it should go? That means up to a b5, in between this, the apart from a and 5b, if there any other string comes, that should be undesirable, and that will leads to the machine to go to trap state. So better to make this one 1 2 3 4, and after that 5b, it must reaches to the trap state. Now at q5 it has already consumed what? A and b5. Now it can take any combinations of a or b. So in this case, if a comes, it will remain in the same state. Now at b, after getting consecutive numbers of a, if it gets b, then it will assume that that b is the last 4b, and in between the, that means and it will take this b and goes to the valid input, right. It goes to the valid input. Now in between this, if a comes, then it should return back to q5 until and unless it is getting 4b, it will not reach to the final state. Similarly at q7, if it gets a, then it should goes to q5 again to get the 4 consecutive b. So why I am returning back to q5? To get 4 consecutive b only. So it will reaches to at up to q9, it will goes to q5 to get 4 consecutive b. Now all the states has consumed a and b except the last state. In the last state q9, if it gets a, then it should return back to q5, but if it gets b, then it should remain in the same state at q9. So this is basically, it becomes little bit complex because the number of inputs are higher, but it is very easy problem. Now let us move back to some more interesting problem. Suppose this problem, LG equal to n a omega greater than, sorry, it should be n a omega mod 3 greater than n b omega mod 3, where n a omega is number of a in omega and